Hello everyone, my name is Kyle Lake and welcome to today's webinar. Today is a tech talk talking about PAD's professional constraint templates and layout templates. So what we'll try to cover today, and hopefully that you'll learn, is how to set up the Constraint Manager to save and use constraint templates. Okay, so I'm specifically going to be talking about the PAD's professional flow today, but this would work if you're utilizing an integrated flow for PADs, utilizing PAD's Professional, or even our Expedition tools. And within the Constraint Manager, you're able to save templates after setting up your design constraints, which can be very useful. You can use those in future designs. Okay, so on the flip side of that, we're also going to be talking about layout template files. Okay, so these will be saved directly into our central library and allow us to have a good starting point for a brand new printed circuit board design in either PAD's Professional, PAD's Layout, or Expedition Layout. Okay. All right, so again, my name is Kyle Lake. I work with Oasis Sales, and if you're unfamiliar with Oasis Sales, we have been a Mentor Graphics, now a Siemens company, premier reseller partner for over 18 years. Okay, so we cover a large breadth of the Mentor Graphics solutions for electronics design, and we're always happy to help you find the correct solution or a new technology to increase your productivity. Okay, so if you are down below in those states that we service, you see the states that we cover. We are in the Midwest and Northwest of the United States, so a good large chunk of the country. We will be your contact for more information on Mentor Graphics products. Our counterpart, TriLogic, is in the East Coast and Northeast side of the United States, and we're just pairing with them in our efforts to educate and deliver these webinar series. So sometimes it's Oasis, sometimes it's TriLogic. I recommend trying to watch as many of those webinars as sound useful to you. But TriLogic has been a premier design community partner for over 30 years, and they're happy to continue to support their customers with Mentor Graphics, now a Siemens company as well. They're based out of Andover, Massachusetts, and again, you'll see below in the states that they service. So if you're unsure who to contact within either Oasis or the TriLogic territories, please feel free to reach out to me, and I can definitely get you the best contact information for who is responsible for the state that you reside in. Okay. There's a little graphical representation. Again, Oasis Sales, the Midwest and Northwest side of the country. TriLogic, basically the whole eastern half and southeast side of the United States. Okay, so if you like what you see today, we do run webinars one a week usually, and they're every Thursday. So if you like what you see, head over to either oasissales.com or trilogic.com, or find that on the YouTube there as the search for just Oasis Sales or TriLogic. You'll be directed to our YouTube channels where we record and upload all of our webinars to ensure that you're able to watch them later on. Okay, so here's my contact information. Please feel free to take a screenshot or just jot that down. I'll show this again at the end of the webinar today. But always happy to answer questions on anything that we talk about today, or maybe just some further advanced topics. Or if you have no idea who to contact in Oasis Sales or TriLogic territory, please feel free to reach out to me. I'll get you the correct contact information. Okay, so I do have everyone on mute if you have not already figure that out. There is a chat box in the GoToMeeting. That's the client that we're using today. So if you just find that chat box, I'll be monitoring that throughout the webinar today. And if it's a relevant question, I will definitely address that while we're discussing it today. Otherwise, I will follow up with any further questions in the days coming up. Okay, so with that, let's just go ahead and hop right into it. Again, just a tech talk today on PAD's professional constraint templates and layout templates. Okay, so just in case you are unfamiliar with the Mentor Graphics offerings in the electronic board system space, here's just kind of a family overview of the different tools that Mentor Graphics and Oasis, as well as TriLogic, all help to support in electronics design. Okay. So Expedition is the enterprise PCB design tool that's widely used throughout the country for high-end PCB Design, so you can tackle some very high-end technologies utilizing Expedition's powerful routing environment, as well as collaborate using its team collaboration for both schematic as well as layout concurrency, and some very powerful data management capabilities built into Expedition Enterprise. On the flip side of that is PADS, and PADS has been around for a very long time. It's a project-based PCB design tool, more of a desktop base for smaller teams, still is very capable of completing high-end technology designs, just doesn't include all that data management and collaboration capabilities that Expedition offers you. Okay, so I do talk a lot about hyperlinks in this webinar series, but today we're not going to be talking about that. But hyperlinks is a family of tools that can check for things such as signal integrity issues, power integrity issues, as well as things that might cause EMI. Okay, so it's a family of tools to have a shift-left mentality in order to verify and analyze your circuit board before we're ever heading to manufacturing. Okay. Valor is on the back end of the printed circuit board design cycle, and what that allows us to do is design for manufacturing checks as well as assembly checks. Okay, so widely used in a lot of board houses and customer sites that want to enhance their yield and make sure that they are going to be able to manufacture and assemble their boards without any major issues. Okay. All right, so let's just hop right into it. So these topics today, while both of them are pretty simple to use, so you'll see that in the demo portion today, both are very, very simple to use. They're very powerful and allow us to actually really cut down on setting up a new design with either constraints or layout definitions really easily. Okay, so what is a layout template? That's just a good place to start. A layout template is simply a stored database that contains the basic parameters to define a PCB project for the layout. Okay, so what is required in a layout template? At a minimum, so this is just the minimum requirements to create a layout template, we want to have the general design parameters, as in the units of measure, the via definitions, the pad stacks, the clearances, and so on. Okay. What can be very important here is a board outline. So if you have a standard board outline that you'd like to start out with, we can define that in the layout template. Okay, along with the board outline, if you're unfamiliar with PADS professional terminology, the route border, which is just essentially the area where we are allowed to route, and that's usually defined straight from the board outline. Okay, and last but not least is the layer stackup, and this is probably one of the more important things that's defined in the layout template, is just the layer stackup. Okay, so you can see in this picture that I have here is we have layer stackup, or I'm sorry, layout templates for starting at 2 layers all the way up to an 18-layer layout template. Okay, so that is a great way if you have your stackups determined, as well as you've used them in multiple designs in the past. You know that their impedance the stackup is going to lend itself to our controlled impedances very well. You've worked with your manufacturer and they say that this is a great stackup to use. We can throw it right in here and we will be able to go ahead and move forward with that. So that was the bare minimum of required information in the layout template. We can also include things such as manufacturing outlines, plane layer definitions in the plane layer setup, mounting holes. If we want to have a standard set of mounting holes, we can have that, mechanical parts, as well as physical constraints. Okay, so if we have our mounting holes, we can have our placement areas and height restrictions all defined in that layout template. Okay. So where are they stored? That's a great question. I know if you're not too familiar with the PADS professional workflow, how things are stored and utilizing the central library, that can always be a little bit confusing. But they are stored directly in the central library, and that's how we are going to use and edit them as well. Okay, so if you're familiar with the library editor in PADS Professional or Expedition, you can access the layout template editor from the tools menu dropdown to copy, create, or delete layout templates. Okay. So what we have done so far is define a new layout template for our new stackup or our new technology, however many layers we want to use. We've defined it. Now how do we use it after we've saved it into the central library? Very, very simple. So you'll see on the right-hand side, I am forwarding a new design to the layout tool, okay? And this is the window that pops up before we even get to the PADS Professional layout space, is what template we want to utilize, okay? So that's just the drop down, and after we've created it, just select that template, hit OK, and it's going to forward into the PCB layout tool with all of our correct data and that template utilized. Okay. All right, I don't see any questions in the chat box. That's totally fine. Just making sure that you guys do know. If you have any questions, please feel free to ask them there. Okay, so layout templates, fairly simple, but yet a very powerful thing and way to cut down on new design time, ramp up time. Okay. So moving on to a constraint template. What is a constraint template? Constraint templates capture the net constraints for reuse on similar nets, and this is a key point here, within your current design as well as external designs. Okay, so they are able to actually capture those constraints, and you can very quickly define them or assign them to a bus in another design or in the current design that you're working with. Okay, so this can be very important for length matching, as well as defining maximum number of vias or a certain type of topology. If we have a custom topology for a 4-pin net, we can define that all within here and assign them to new nets in that design. Okay, so again, very powerful thing to do, as well as a very simple thing to do within the Constraint Manager. Okay, so essentially all we have to do is first specify the constraints that would either promote the signal integrity for one bus, and in this example, for a 64-bit bus. Then all we have to do is right mouse button click on that net in the Constraint Manager and create a constraint template. Okay. Then on the rest of the 63-bit in that bus, just go ahead and right click on there and assign that constraint template to the rest of those bits. Very, very simple, but allows us to define the constraint once and use them in future designs for all of your bits there. Okay, so this can be really helpful for DDR, for example. If you have all of your DDR constraints set up correctly, you can just create a constraint template and then utilize that in future designs. If we're using DDR3 and 3 designs, really helpful to make sure that we have the design constraint set up correctly in the first design, create a template, and basically we won't have to go through creating the constraints for all of our DDR buses in our future designs there. Okay, very simple to use constraint templates. I basically outlined the process here, but in the Constraint Manager on the Nets spreadsheet page. So this is the only way you can actually use constraint templates is in the Nets spreadsheet. Okay, so we can apply these constraints to a single-ended or a differential pair, and all we have to do again is right mouse button on there and hit Create Constraint Template. Okay. So all we have to do to apply those constraint templates to other nets is utilize the main drop-down filter, and there is a template column that we allow a drop-down in there that we can just specify which constraint template my nets are going to use. Or again, we can just right mouse button click and apply those constraint templates to them. All right, so that's all the slides I was going to do. Let's just go ahead and hop directly into the tool now. Okay, so just to talk a little bit about PADS Professional and what it can work with. In PADS Professional VX 2.4, we do have the ability to launch the library tools standalone. Okay, and I'm just utilizing here on the bottom a Windows toolbar just to make things a little bit easier to work with. You can create these really simply by just right-click on the toolbar, and new toolbar. This allows us to have a pull-up directly from this toolbar and go into the PADS Pro library tools. Okay. Okay, launching the library tool standalone, this allows me to go ahead and open up a central library. Okay, again, so the central library is accessed by DX Designer as well as Pads Professional or Expedition Layout, and allows us to go ahead and edit the actual central library. So library.lmc is the central library that I'm going to be utilizing in the demo for both constraints and layout templates right now. Okay, so this opens up the central library editor. If you're not very familiar with this, it's pretty simple to understand. We have three main partitions here for parts, cells, and symbols. I can actually just go ahead and take a look by single clicking. I just get a preview of the symbol, as well as single clicking on a cell or footprint, and it just gives me a preview of that. Okay. I talk more about the central library in other webinars, so if you'd like to learn more, try and find those on our YouTube channel. Okay, so to go ahead and look at layout templates, I am going to go to Tools, Layout Template Editor. Okay, so this opens up our templates that we have available. So what we can do within here is look at multiple different types of templates. Okay, so we have the first one that I was going to look at is PCB Design. Okay, so that's just our PCB layout template. The other things in here include a drawing template for the drawing editor, package design if we're utilizing a bare die or chip on board type of design, panel design if we are going to be panelizing it within FabLink, PCB design within Pads Pro layout, as well as a rigid flex design. Okay, so these are just our different partitions here, and I can have different layout templates depending on which pull down I have. Okay. So we're just going to be working with PCB design today. And there's a few things I can do here. I can just go ahead and create a new template, and I can look for a source design file if I wanted to actually go ahead and copy the template directly from a PCB. Okay, so if I have a PCB that I want to create a template from, all I have to do is browse to it within here. And give it a template name. Okay, so this will go ahead and create a template for me directly from that PCB file that I just pointed to. Okay, so this is going to bring in the stackup, the board outline, and all of the other required information from this PCB file into that template. Okay, so that's just one way to create one. What I can also do is I can go ahead and copy a template. So if I click on the template name and hit copy template, this will create it again. And I'm going to call this Kyle 10 layer. Okay. So once I have that defined, I can click on this third icon here just to actually start editing this template. Okay, so I want to make some changes to this particular PCB template. And what this opens it up in is basically Pads Professional Layout Tool. Okay. So if you're familiar with the layout tool, this template editor will feel exactly familiar. And all we're going to do here is maybe delete some fabrication notes as well as the stackup picture that I have in here and change the stackup. Okay, so again, what we have within here, by default, I'll zoom out a little bit, we first off have a sheet border. Okay, so you can have a border defined in this template for us. You'll see we have a lot of assembly or fabrication notes that we can include directly in the template as well. So as soon as I start this new PCB, it will have all of this information, as well as this stackup drawing. Okay, so what I'm going to do here first is I'm just going to delete this stackup. We're not going to utilize that for us. Okay, if I want, I could go ahead and change the order. We'll just change some of our border dimensions for us. Make it slightly smaller. I'm going to delete these fab notes. Actually, we'll keep those fab notes for us. I'll just delete this drawing. Okay. So if I wanted to, I can also go ahead and import information in DXF or IDF. Okay, so this will bring in like a company logo, for example. If you have it in DXF, we can place that directly in our layout template. So it will always be utilized in every PCB that we start with that template. Okay, so that's a really good thing to start with in those layout template files. Okay. So what I've done, just changed the route border, the board outline itself, deleted some information for the stackup. Now, if I go into my stackup editor, I can start playing around with this as well. Okay, so I'm just going to really quickly do some stackup information changing. If you're unfamiliar with this, I'll kind of go over it here. If I right-click on this Signal 8 layer, I can hit Insert Below. And if you know exactly what you want, you can do that, or I can hit Most Suitable. And that's going to put in a dielectric layer because it knows that there was a dielectric layer below it and needs another one before I can add a signal plate layer. I'm going to insert below a split mixed, and I'm going to call this plain _1. Okay. I'm going to do the same thing up here to make this a 10-layer board. I'm going to click on signal layer 1, insert above, the most suitable. We get another dielectric, insert above, and I'll do one more split mix plane on the top and bottom. Okay. One thing I do want to show out of here, if you're unfamiliar with the stackup editor, we do have impedance planning. Okay, so this allows me to solve for differential pairs or single-ended traces for a target impedance, and it tells me the width that I should be routing for that particular target impedance. Okay, very simple. What you can also do is if I click on this icon here, we will copy to clipboard as manufacturing documentation. And if I open just a Word editor, for example, well, I guess I'll go ahead and go into Paint. My Windows, Microsoft Office is changing around a bit, but there's that layer stackup. So I just copied it to the clipboard from the stackup editor directly into Paint, and I could bring this into my layout template directly from this as a DXF file if I wanted to, or just copy and paste it there. Okay. So that is all from the stackup editor. I'm going to hit File, Apply, and Close. And we should be good to go now. All right, so now all I have to do is I'm going to hit Save, and that's going to save my layout template. All right, now I'll exit. And now, again, in that central library, we have a Kyle 10-layer template as well as that sourced from the PCB file template that I created. Okay. All right, so to show how to utilize this template now, I have a project file that does not have a PCB file associated with it yet. Okay, so this will be the first time I'm forwarding onto the layout tool. And just to show that, I can go Paths, Professional Layout. And this is going to pop open the New Design dialog box. Okay, so here I can choose my design technology. And if I wanted to have a rigid flex, I could have created a rigid flex template within there. But since I don't have a template for that, I will go ahead and see I have Kyle 10-layer template that I just created, as well as that Source Pro eval template. Okay. I'm just going to click on my 10-layer template that I just used, hit OK, and it's going to go ahead to create that PCB file for me, as well as forward it onto the layout tool. Okay, so while that's opening up, I'm going to go ahead and open up another instance of DX Designer. All right, so you'll see Pads Professional is starting up for me. And again, it should forward annotate all of my information to the PCB and allow me to see that template that I utilized. I'm going to hit yes on forward annotation. And we'll see that this has that board outline that I had, as well as all my fab and assembly notes and my title block for this particular design. Okay. All right, so it's doing the forward annotation right now, and then we will be able to go ahead and start placing parts. All right. So let's hop back into the DX Designer space. All right, so let's just do this forward annotation here. I'm going to begin that forward annotation process. And if you're unfamiliar with the forward annotation, what this does is it packages the design in the schematic tool, as well as forward annotates everything necessary into the layout tool. All right, hopefully this completes here in just a second. All right, so once we have all green dots in the project integration dialog, that just signifies that we have all of our changes forward annotated into the PCB file. Okay, so that's the same in the bottom right hand side. We can see that we have 3 green dots showing that we have everything totally in sync. Okay, if I wanted to start placing components, if you're unfamiliar with Pads Pro, I can just do Place Component Explorer, and this allows me to just start dragging a component one at a time onto the PCB. Okay. Or I can actually drag and drop these component groups with the PCB. And let me turn everything on so we can actually see. There we go. So this is just kind of our floor planning capability within Pads Professional. This has our component groups, and if I wanted to just place those, I can place them all on all levels, and they will just start being arranged for us. Okay. Just to talk about a little bit more about that forward annotation. So if I am in the DX Designer space here, and let's take note of those green dots in the bottom right-hand side of our screen there. As soon as I would go ahead and create a new resistor, for example, you'll see that my forward annotation lights in the bottom right-hand side of my layout tool there turn from green to yellow. And to do that forward annotation, I can just double-click there or go to Setup, Project Integration, and do the forward annotation directly within here. Okay. So that's starting a new PCB with our layout templates. Now let's go ahead and hop into the Constraint Manager for those constraint templates. All right. So if I want to go to Tools, Constraint Manager, that can be very powerful. Okay, so this is the Constraint Manager. If you are unfamiliar with the Constraint Manager, I do have a video on the YouTube channel that kind of highlights all the capabilities within here. It's a little bit powerful and a little bit daunting at first as well, but after you've played around with it for one, maybe two designs or used it for a little bit, it actually makes a lot of sense, and you can control all of your design constraints in this spreadsheet-based system. Okay. So we've got net classes, clearance classes, as well as constraint classes. Okay, so clearances, these are just all physical clearances on a layer by layer basis. Net classes are groups of nets that we can control trace width and impedances, as well as via assignments on a layer by layer basis. And then finally, in our constraint classes or nets spreadsheet down on the bottom, this is where we have all of our actual nets defined. Okay. So what I can do within here, just to kind of show the interoperability between the Constraint Manager and the schematic, is if I select the cross-probing icon on the top of the Constraint Manager, I'm able to actually cross-probe between the schematic and the Constraint Manager. So you'll see if I select a net, it's going to go hop to that page in the schematic as well as select it for us. Okay, so it can make selection very easy. What I can also do from the schematic is if I select the net, you'll see it highlights it in the Constraint Manager. I can select multiple as well. Okay, so that's just an easy way to understand which net you're working with, or select the net from the schematic and then have it highlighted in the Constraint Manager. Okay, so just to look at all of the different types of constraints that we can actually enter within here, there's a very powerful and important drop-down in the Constraint Manager. So this is the drop-down, and it basically filters all of the information that we are able to see in our current view. Okay, so if I go just to the All filter, I'm actually able to see all of the different types of constraints that I can enter in on my nets here. Okay, so you'll see we've got some lengths. We go down to formulas. If we're getting very powerful, we can actually enter in formulas that would be calculated based on different net lengths. For example, we can put in some signal integrity constraints for maximum and minimum overshoot, which would be carried into the hyperlinks tool if we're going to be utilizing that for some signal integrity analysis, and then some simulated delay as well. Okay, so a lot of information within here, but to make it things a little bit easier is we have all of these filters again. Okay, so if I wanted to, I can create a new filter group specific to myself. What I typically work with is I'll look at my delays and lengths a lot. This is probably one of the more important filters here. We can have a maximum length based on which layer it's going to be routed on, or we can just define a pin-to-pin type of length delay. Okay. So if I scroll down here to my address bus, I want to start entering in some constraints for this address bus here. And what I can do, if I want it to be a length, as in thousandths or mils, or I can change it to time of flight, and TOF is time of flight in nanoseconds. So I can define length constraints in either thousandths or in nanoseconds, just determining on what you are more comfortable with. Okay, so for example, on this address bus, I'm going to use my length requirement here. Okay, so if I wanted to just start defining a minimum and maximum length there, all I have to do is type in 1500 to 2000 mils. Okay, and if I want to create a match group, all I have to do is type in a text phrase here and then a tolerance as well. Okay, so this will create a match group. Any place else that I put in Kyle_match will have to match this net length within 50 mils. Okay, so if I've gone ahead and defined these requirements here, all I have to do now is say create constraint template. Right mouse button on that net and hit create constraint template. Okay, And I'm just going to call this address bus length, and then I can put in a description. Okay, that's all I have to do. Now if I wanted to just select some different nets here, I can just right-click on these and hit Apply Constraint Template. All right, that's all I have to do here. And we can see that I have that address bus constraint template that I just created and gives me that description. Okay. Okay, so as soon as I applied that, it's going to give me first a report on what was matched between my source that I created it with and all of those other nets. Okay, so it gives me just a nice overview of the pins and the net information, and if it matched between what I created the constraint template with and what I applied it to. Okay, so this is just a good report to understand if you are going to be utilizing those constraints correctly. But you'll see, as soon as I did that, it applied all of the constraints I already had to the other nets that I just applied it to. Okay. So for example, let's just go ahead and create another one really quickly. If I wanted to change from delays and lengths to my routing, for example, I can go ahead and change, let's work with our bus bar bus here. If I want to change my net class, first off, I can do that as well. I'll change this to an FData net class. I can change this to a different type of topology or how the net lines are defined from pin to pin, and I'll do a chain topology there. With chain topology, I can set a maximum stub length, and let's just go ahead and do that. And then lastly, I'm going to set a maximum number of vias as well as how many number of test points I'm going to require on this net. Okay. So this is just showing the different type of information that I can actually save within my constraint group. All right. So again, if I wanted to create a constraint template, just right-click on that net, and I'm going to call this bus topology chained stub length and vias. All right, so that created that there. Now if I want to go to my main dropdown, I'll show another way that we can actually apply these constraint templates. Okay, so we'll see I have a template column in this main filter here. All I have to do here is change what template I'm working on, and I'm going to hit bus topology. Okay, so as soon as that happens, we can kind of see that it changed to this topology as well as the net class information, okay, because I saved that net class info to the same topology as well. Okay, so as soon as I do that, I can do it this way as well. This is a little bit quicker if I wanted to just go right-click, apply constraint template, that one more bus topology. All right, so I've applied those. I'm going to go back to my routing capability, and we'll see every other bus bar bit or net that I changed to that constraint template has changed all of this information. Okay, so it can have lengths, it can have maximum number of vias, net class, topology, lots of good information that we can just save in those constraint templates. And again, I can utilize these constraint templates in other designs that are using this central library because these constraint templates are saved in the central library as well. Okay, so that's all I was planning on showing today. I don't see any other questions in the chat box right now, but if you do want any more information, please feel free to reach out to me. Again, this is recorded. I'll send out a link to the recording in just the next day or so. And if you have any other questions, please let me know. I do see That's a great question. So I see Ted Casper just asked, are the constraints you entering saved to the project or to the template? And they are saved to the central library itself. Okay, so they're not project-based, it's not template-based, it's not the PCB template. They're two independent things. Those constraint templates are saved into the central library. So any other project that you are utilizing the same central library with, you should have access to those constraint templates you just created. Okay, again, thanks for coming, everyone. I appreciate it. If you have any questions, reach out to me, and I hope to see you in a future webinar that I'll be hosting. Please feel free to reach out to me if you have any questions. Have a great day.